Hello students. In the previous video of digital electronics, we have seen how we can derive Boolean expression with the help of given circuit diagram. So in that all those questions, the circuit diagram was given to you and you are supposed to find Boolean expression at the end of the circuit diagram. That is what your output of final gate, that logic gate's output will be your Boolean expression. Now here in this video we are going to see how to realize logic circuit from Boolean expression. That means I want to tell you the circuit diagram you are supposed to find and Boolean expression is given to you. So therefore, exactly opposite exercise we need to do in this particular case. So let us start with the first question. Here, the question is given. You have been given the logical equation, which is the output of the previous exercise. That is y is equal to AB plus AC. Again, let me remind you again that AB means it is A dot B and AC means A dot C. The question is design a circuit using gates to realize this function. So you are supposed to now create a circuit which is going to give you output as this Boolean expression given in the question. So let us start with the steps. First of all, identify how many terms are present. Here you can see that there are two terms present and between the two terms the sign is plus sign, right? The plus sign means we know that it's a equivalent to which gate? Plus sign means it is equivalent to OR gate. So that means these two terms are acting as an input to the OR gate. So your circuit diagram is going to include OR gate as the final step, right? That OR gate will have two inputs, right? That OR gate will have two inputs and output will be this one, right? The given in the equation. Now, after that, let us focus on this first input, right? In the first input, the input is not only single variable, it is made up of two variables, that is a, b, which is nothing but a dot b. So when I say a dot b, that means this dot represents that it is having an AND diagram, right? AND logic. So therefore, for first case, you have to create a AND, right? AND gate between a and b, right? So there has to be a AND gate between A and B. Here also AND gate between A and C, right? A dot C, that means A and C. So therefore, now we are clear that there will be three inputs A, B and C, out of which A and B will be connected to one AND gate whose output is given to OR gate, and there should be another AND gate to which the inputs will be A and C. So I am clear with the concept now. Now I am going to draw the circuit diagram. That is, I am going to design a circuit diagram using those gates. So the circuit diagram will look like this. First of all, there will be inputs. So I am writing down the inputs A and B. And those two inputs will be given to the AND gate, right? So I'm drawing the AND gate and its output is like this. You'll now realize that this is an AND gate whose output is A dot B, or we called it as a AB in this case. And since there's another input or another variable, Boolean variable C, and this C is not connected to this AND gate, it must be connected to another AND gate, right? So therefore C will be connected to another AND gate like this. This is one input of AND gate, and another input will be taken from this A, right? So I'm drawing a dark small circle here and this AND will be connected to this second AND gate, right? So this leg, that is A terminal, is connected to first AND gate as well as second AND gate. The output of this AND gate will be, dear students, AC or A dot C. Now these two outputs must be connected to which gate? OR gate, because there is a plus sign. So therefore these two will be connected to OR gate. I'm drawing the OR gate first. And the inputs of these two are, this OR gate will be, this will be first input and this will be second input. So therefore you can see the output will be Y is equal to AB plus AC. This is how easy it is. That is to design a circuit using the gates, right, where the function is given to you as AB plus AC. You need two AND gates to represent the logic of AB, that is A dot B and A dot C, and you required a plus sign, that means you required OR gate, so that this plus can be equivalently represented by the given gate, right? So this is how you can solve first question, very easy one, right? So now little bit difficult one, is it? So let us see. This is the logic equation. Y is equal to A. Since nothing is present between the bracket and A, that means it must be dot. So A inside bracket complement of B plus complement of C. Now when you want to create complement, you'll always remember you have to use which gate? Yes, NOT gate. The effect of NOT gate only to create the complement of the input. Since complement of B, that means B will be connected to the input of NOT gate. C also will be connected to the input of NOT gate. These two will be added, that is plus sign, that means there has to be which gate? There has to be OR gate, right? And there is no sign between A and this bracket, that means there has to be dot, and that dot means we need to use which gate? AND gate, right? Right, so therefore these three gates we are going to use in the circuit diagram. So let us see. First, identify how many inputs are there. Different variable names has been used as A, B and C. So therefore I am writing down those names again here as A, then next name may be B, and next will be C. Now A will be connected directly to this AND gate, but before that, take a look at this. It's not B, it's a B complement. So therefore B signal will be given to which gate? NOT gate, which will create B complement, and C also will be given to another NOT gate, which will create a signal, right? C complement. Now these two signals here you can see they are, these variables are added, that is OR gate has to be connected between the two. So therefore these two will be given as a input to this OR gate, right? So therefore I am joining these two outputs as B complement and C complements to the inputs of this OR gate. And now the output of OR gate is what? B complement plus C complement, right? Because of presence of OR gate. Now this will be ANDed with this A. So therefore this A will be connected to which gate? Right, AND gate. So therefore these two will now act as an input to this AND gate, and the output of AND gate will be what you desired. So therefore here the output you will get is Y is equal to A dot B complement plus C complement, right? So therefore this is how you can solve the second question. Very easy one, right? Design a circuit with the help of given logical equation. Let us focus on next one. Now this is a little bigger one. There are three variables that we need to use, right? A, B and C. There are dots, there's plus sign, there's bracket. So let us see what is going to happen. So there has to be three variables, right? So three variables are A, B and C. First, we need to see there has to be B dot C, right? B dot C, that means the gate which should be connected between B and C must be AND gate. So what I am doing is I am connecting these two as input to AND gate. Okay. Now the output of AND gate, which will be, right, B dot C. Now this B dot C is added with A, right? That means A must be connected to one OR gate. Am I correct? Right? A must be connected to input as a OR gate. So these two will act as a input to this OR gate. Right? Because of which the OR gate's output will be A, which is coming as one input, this, and this will be another input, but this will be plus B dot C. Is that okay? Right? So now you get this bracket done. Now this bracket is nothing but input for AND gate because of the dot present between these two brackets. These two brackets are inputs of another AND gate. That means we have to create one more AND gate. But first of all, let us solve this and bracket one. Out of this bracket, now this bracket has got these two inputs and plus sign between the two. That means there has to be OR gate. But this is not simple one. This is C complement. That means we need to create a signal as a C complement from the input C. So this C complement will be now ANDed with A. Then output of that will be added with B. Right? So therefore, I am going to create first a C complement. Let us see. Let us connect wire somewhere here. Right? And connecting a NOT gate here. This NOT gate indicates that signal created is C complement. And this signal is given as input to which gate? Dot, that means AND gate, right? So this will be given to input as a AND gate, right? And another input of AND gate will be A, right? So therefore, connect a wire somewhere here, connecting the wire. So therefore, dot dark circle, and this wire will be connected to this AND gate. The output of AND gate will be which one? C complement dot A. Right? A given as an input, right? This is A and this will be complement of C, right? Because of NOT gate connected here. Then this will be, this output is nothing but input to another gate whose another input is B. Why? Because plus sign present here. So therefore, I need to get this B signal somewhere here so that I can easily connect it. So therefore, what I can see, yes, there is a gap. Yes, somewhere here. Okay, so this dark circle, that means here connected, and this is going to act as an input to another gate which will be OR gate. Why? Because plus sign. So this is B and this will be the OR gate present. Output of OR gate now will be B plus C complement A. Now these two brackets we have derived, right? So these two brackets will be now ANDed because of the dot present between the two brackets. So that means these two outputs will be given as input to another gate. Wait, what will be the gate? It will be AND gate. and the output of this AND gate, dear students, will be the required one, that is y is equal to first input, that is first bracket a plus b dot c dot second bracket will be b plus c complement dot a. That's it. This is how you can realize the circuit using this logic equation. Let's try next one. Here equation is y is equal to ab plus ac bar plus bc. So here you have three inputs, a, b and c. Now the first term of this circuit, first equation, you can first term of the equation is AB. That means between the terminals A and B there has to be AND gate connected. So I'm drawing, right, this little further, and this will be the AND gate, right? The output of AND gate will be A dot B or AB simply. Then you require C complement so that second term can be realized. So to get C complement, I have to connect NOT gate, and input of NOT gate will be C and output of NOT gate will be what is desired is C complement, right? Now this C complement will be ANDed with A. So that means I require signal A. So let us get that signal A here. This will act as a input to the gate, another gate, AND gate. So the AND gate's two inputs are this A, right? This is connected, so therefore dark A and C complement of C. Therefore the output of this AND gate will be C, A, C complement. Then I require BC, that means this B and this C. So therefore these two must be connected to another AND gate. So I am going to connect another AND gate over here. This is the signal B and this is the signal C, right? This should be connected to another AND gate, and yes, this is BC, right? B dot C. Dark circle. Now these three, which are the outputs of respective AND gates, will be now added. All three will act as a inputs to another gate, and which gate? That will be OR gate because of this plus sign. So therefore I am drawing simply first the OR gate, which is going to receive three inputs. The first input, the second input, and third input. Now these three inputs, since given to OR gate, so OR gate's logic is provide plus sign between the inputs. So therefore you will be AB plus AC complement plus BC. This is output of this OR gate, which is what expected from you in the question. So let us try next question. Now this is little again complicated one, but I will definitely explain you so that it will be not that difficult for you guys. Now see, this is NOT gate application, right? Inside it there is AB, BC plus AC complement. So therefore ultimately you are going to use three inputs as A, B and C. These three inputs are A, B and C. First of all, first term which is inside NOT gate, the first term is AB. So here you are going to connect the AND gate between these two terminals, right? So I am going to get these two terminals and connecting AND gate between these two terminals. So output of this AND gate is A dot B. Then BC, so therefore from C there will be one terminal, and from B there has to be one connection. It should be connected to another AND gate, right? So output of this AND gate will be BC. Then AC complement. So therefore C must be complemented. There has to be one wire from A also. Therefore I'm taking first wire from A. Okay, and you require C complement. So wire from C must be connected to NOT gate, that is bubbled, before getting connected to input of another AND gate. So this will be third AND gate. Its output will be, this is input A and this will be C complemented, therefore C because of this NOT gate. So what you get is AC complement, right? Now this AC complement and AB and BC all are added together inside that inside that negation. So therefore first all these three must be connected to OR gate, right? So that we'll get effect of addition. So therefore drawing the OR gate first, then first input of this OR gate will be A plus B, sorry, AB, sorry. Then there will be BC and third input will be this one. And this is going to create the output as AB plus BC plus AC complement. But this is not we want circuit which should be realized like this. That means this has to be complemented. So when there is a complementation, that means we required a presence of NOT gate out the output set. You can simply substitute this by NOR gate also, that is draw bubbled over here, you will get the desired output. But I am just showing you the presence of NOT gate. So output of NOT gate will be what you required, that is Y is equal to complement of AB plus BC plus A complement of this C. So this is how this logical equation can be realized with the help of circuit diagram. Let's say this one again, there is a negation, but now negation of these additions and then there is a multiplication also. Now these two brackets are processed with the help of AND gate here, then there is a OR gate between. So overall there are three, right? Three signals A, B and C. So let us draw those signals. A, next second will be B and third will be C. Now these three signals have been drawn. First of all, find the first bracket A plus B. So A plus B, that means it must be connected to OR gate, right? So I'm drawing OR gate between the two. So the output of this OR gate is A plus B. There has to be another OR gate which is going to give you A plus C. Therefore, this A must be given as an input to another gate, which is again OR gate, and that OR gate is going to receive input signal from another C, right? So the output of this OR gate will be A plus C, right? Input is A, this will be C. Then third bracket B plus C complement. So that means there has to be one connection at B, taking input from B, and one more input from C. But we don't want C as an input, we want C complement. So connecting NOT gate here and then given output to which gate, since there is a plus sign between the two, so therefore not this will be OR gate, right? And since this input is what, this is B received, this is C complement received, so the output of this OR gate will be B plus C complement. Now these three outputs of OR gates are ANDed together, so therefore there should be one AND gate which must receive all three inputs, so that those three will be ANDed. So therefore this is first input, this is second input, and this is third input of the OR AND gate. And this AND gate, you can see it is complemented. So either in the previous case I draw NOT gate, instead of that you can represent this by this simple bubble. Instead of drawing that entire NOT gate, you can draw simply this bubble, which will give you the effect of NOT gate. So the output will be Y, which is given in the question itself, right? Let us see next one, easy one, right? There are 4 inputs, A, B, C, and D. So therefore, getting those 4 inputs. So let's change the ink. One second. Yes. Let us change the ink. Yes. So A, B, C, and D. First we want A plus B. So therefore A plus B means these two must be connected to inputs of OR gate. So I have drawn OR gate. So now you get output as A plus B. Then there has to be complement of it also. So that means instead of connecting simply OR gate, you have to connect one bubble over here, which will create complement of A plus B, right? Which is nothing but a NOR gate, right? NOR gate, right? Now this output must be connected to the input of which gate? AND gate, right? Because this has to be dot between the two. So therefore this must be connected to AND gate. And this, another input of this AND gate must be this. Right? So the output of this AND gate is input this, that A plus B and its whole complement dot C, which is nothing but this one. Now this output will be given as input to another gate. Which one? Plus, that means OR gate, right, students? So there has to be OR gate, and D must be another input of that OR gate, and this will be the OR gate. Now this OR gate receives this as an input and D as another input. So obviously the output of OR gate will be what you required is A, Y is equal to A plus B ka complement. This is what I'm talking about, dot, sorry, C plus Y plus, because OR gate, and second input is D. Remember student, this is not C plus D first, right? This is not C plus D first. Okay. So this is how you can realize the circuit diagram with the help of this equation also. Okay. Yes, and this is the last expression that I am showing to you. So therefore, with the help of these many examples, you can easily get the final output of a circuit diagram with the help of given logical equation, right? So we have seen in the previous video how to find equation by using circuit diagram. Here we can see how to find circuit diagram with the help of given logical equation.